Hello and welcome to Algebra 2 Lesson 4. In this video, we're going to continue learning about solving linear equations in one variable. So now we're going to deal with some special case scenarios. So the first thing I want to talk about today is what to do when you have a linear equation in one variable and you have fractions involved. So typically, to make it easier on ourselves, we want to clear the equation of fractions before we begin. But as I'm going to show you with this first example, you don't have to do that. Okay, you'll get the same answer either way. So to clear an equation of fractions, we multiply both sides by the LCD, that's the least common denominator, of all fractions. So here is an example. I have negative x plus 1/5 x is equal to negative 21 fourths plus 14/5 x plus 3/5 minus 1/2 x. So to not deal with these fractions, I can just figure out what the LCD is. So I have a 5, I have a 4, another 5, another 5, and a 2. Now really the only thing I need to think about is the 5 and the 4. 5 times 4 is 20, so the LCD here would be 20. So what I want to do is I want to multiply both sides of the equation by this number 20. So let me just copy everything. So it's negative x plus 1/5 x, and then I'll close the brackets there, and then I'll put equals, put some new brackets. We'll have negative 21 fourths, and then plus 14/5 x, then plus 3/5, and then minus 1/2 x. Close the brackets, and then we're multiplying this by 20. All right, let's scroll down and get a little room going. So I'm going to use my distributive property. I'd have 20 times negative x. That would be negative 20x. And then next I'd have 20 times 1/5 x. So let me write that out. So plus 20 times 1/5 x. So here's where we're going to do some canceling. This 20 would cancel with this 5 and give me a 4. Then 4 times 1x, or 4 times just x, is 4x. So let me erase this and just put 4x. Okay, then we have equals. Now next I have 20 that's going to multiply negative 21 fourths. So let's write that out. So negative 21 fourths times 20. And of course I can do some canceling here. This 20 will cancel with this 4 and give me a 5. 5 times negative 21 is negative 105. Let's erase this and put negative 105. Then I'll have 20 times 14/5 x. So plus 20 times 14/5 x. And what's going to happen is this 20 will cancel with this 5 and give me a 4. 4 times 14 is 56, then times x is just 56x. Let's write 56x here. And then I have 20 times 3/5, so plus 20 times 3/5. And this will cancel with this and give me a 4. 4 times 3 is 12. So this would be 12. And then lastly, I'll have 20 times negative 1/2 x. So I'll put minus 1/2 x times 20. And again, this will cancel with this and give me a 10. 10 times negative 1 is negative 10. So this would be minus 10x. So minus 10x. So it took a while, but we've cleared our equation of fractions. And now what we can do is just proceed as we normally do. We would simplify the two sides separately. On the left side, I have negative 20x plus 4x. That is negative 16x. On the right side, I can combine 56x and negative 10x. That would give me 46x. And then over here, negative 105 plus 12 is negative 93. So this would be 46x minus 93. And let me scroll down and get a little room going. So now what I want to do is put all the variable terms on one side and the numbers on the other. Really all I need to do is subtract 46x away from each side of the equation. So this is going to cancel. Negative 16x minus 46x is negative 62x. And this equals negative 93. One last step for us here. We want to divide both sides of the equation by negative 62. So we can isolate our variable x. So what's going to happen is this will cancel with this and give me a 1. So I have x by itself. And this equals, we have negative 93 over negative 62. Let's see if we can reduce that any. I know that negative 93, I could write this as negative 1 times 31 times 3. And I know that negative 62, I could write this as negative 1 times 31 times 2. So we can see that we can cancel the negative 1 with the negative 1. Obviously, negative over negative is positive. We can cancel the common factor of 31. And what I'm left with here is 3/2. So I can erase this and just put x is equal to 3/2. So again, we've been using this solution set notation. And so inside of set braces, I would just list 3/2. And we're done there. Now, normally in Algebra 1, I checked everything. I would go back and I would substitute 3/2 in for x, and it would show you the left and the right side are equal. As these problems get more complex, it's more time consuming to do that. So my strategy for you is pause the video, go ahead and check it. Now, if you're on a timed examination, you might say, hey, what do I do? Should I check everything and not finish the whole test? The answer to that is no. If you have a lot to do on your test, complete the test. Don't check anything. Once you're done, where students would normally rush up to hand in their paper and run out of the classroom, take the extra time to go back and check the ones that you're unsure of. You do those first. Then you go back and you check as many other problems as you can. Hopefully you can check all of them, and then you'll catch any silly mistakes that you've made. Now I want to show you one thing before we kind of move on to the next example. Let me erase everything. So I want to quickly show you that you get the same answer whether you clear the equation of fractions or you don't. So over here, I have negative x plus 1/5 x. To get a common denominator going, I could just multiply this by 5 over 5. And what would that give me? It would give me negative 5x plus x over 5. Well, this would be negative 4x, right? Negative 5x plus x is negative 4x over the common denominator of 5. So that's the left side. So negative 4x over 5. Now this is equal to, over here, to get a common denominator between here and here, I see I have a 5 and a 2. So if I multiply this by 2 over 2, and I multiply this by 5 over 5, what I'm going to have is 28x over 10 minus, over here I'd have 5x over 10. So I have a common denominator. 28 minus 5 is 23. So this would be 23x over 10. So 23x over 10. Let me erase that. And now the other thing we have to deal with is this right here. So to get a common denominator here, I'll multiply this by 5 over 5 and this by 4 over 4. And what would happen is I'd have negative 21 times 5. So that would be minus 105 over 20. And then plus 3 times 4 is 12. So 12 over 20. So if I sum negative 105 plus 12, I get negative 93. So this would be negative or minus 93 over 20. Now, let me scroll down and get a little room. To get all the variable terms on one side, I would just simply subtract 23x over 10 away from each side of the equation. And of course, to do that, I need to have a common denominator. So I would take negative 4/5 times x, and I'd multiply this by 2 over 2. And that would give me negative 8/10 x, and then minus 23x over 10. So when we look at this, really we think about negative 8 minus 23, and that's negative 31. So what's going to happen here, this is going to become, on the left side, negative 31 over 10, and this is times x. Okay, this is going to cancel over here and be 0. So this will be equal to negative 93 over 20. Now, how do I get my solution here? Let me scroll down a little bit. In most cases, we see something like this. We see, 5x equals 60. And we divide both sides of the equation by 5. That's the coefficient of x. This cancels with this, and I get x is equal to 12. But in this case, we don't have something that looks like that. But we really do. I can still divide both sides of the equation by negative 31 over 10. But there's a quicker way to do that. You multiply by the reciprocal. So when your coefficient for x is a fraction, you multiply by the reciprocal. Remember, all I'm trying to do is get x by itself. And multiplying something by its reciprocal makes it equal to 1. So if I multiply this by negative 10 over 31, the negatives would cancel, and then 10 would cancel with 10, 31 would cancel with 31. So this is 1 times x, or just x, is equal to, I've got to multiply by the same thing over here, so that's legal. So times negative 10 over 31. We know already that the negatives would cancel. And we know that if I think about 20 and 10, this would cancel with this and leave me with a 2. Between 93 and 31, this would cancel with this and give me a 3. So I end up with x equals 3 halves, just like I did, okay, when we looked at it by clearing the equation of fractions. Now, in this particular case, you could make the argument that it wasn't any faster to clear the equation of fractions. But I think, especially if you have kind of a simpler problem, it kind of is. So it's a personal preference whether you want to work with the fractions or you don't want to work with the fractions. But in either scenario, you're going to get the same answer. All right, for the next one, I'm looking at 2 times the quantity, x minus 5 thirds. This is equal to 11 thirds minus 3 halves x. Now, if you have a problem, okay, where there's fractions involved, you don't want to clear anything until you have removed all the parentheses and brackets, all the grouping symbols that you have to deal with. So what I would do here to start the problem, multiply 2 times x, that's 2x, then minus, you'd have 2 times 5 thirds, that would be minus 10 thirds. Then this equals 11 thirds, and this is minus 3 halves x. Now it's very easy to clear the fractions now. We come through here and we look at the denominators. I have a 3, and a 2. So what is my LCD? Well, it's just 3 times 2, which is 6. Now, if I multiply both sides of the equation by 6, I'm going to get what? So 2x minus 10 thirds equals 11 thirds minus 3 halves x. Multiply this by 6 as well. So let's go ahead and crank this out. So 6 times 2x is 12x. 6 times negative 10 thirds. So let's put minus 6 times 10 thirds. And we know that the 6 would cancel with the 3 and give me a 2. 2 times 10 is 20. This would be minus 20 here. And this equals, we have 6 times 11 thirds. So 6 times 11 thirds. 6 would cancel with 3 and give me a 2. 2 times 11 is 22. So this is 22. And then last we have 6 times negative 3 halves x. So minus 6 times 3 halves x. And this is going to cancel with this and give me a 3. 3 times 3 is 9. So it'd be minus 9x. Okay. So now we're done with that. And we have an equation without any fractions involved. I want all my variable terms on one side, all my numbers on the other. So let me add 9x to each side of the equation. So this is going to cancel, become 0. And then also let me add 20 to each side of the equation. So this will become 0. And 12x plus 9x is 21x. And this is equal to 22 plus 20, which is 42. So one last step here to solve this. I want to isolate x. So I divide both sides of the equation by 21, the coefficient of x. What's going to happen is this will cancel with this and give me an x. And then 42 over 21 is 2. So my solution set here contains one element, just the number 2. All right, so now let's move on and talk about equations when there's decimals involved. So I have here that similarly, when an equation contains decimals, we can clear the decimals by multiplying both sides by the appropriate power of 10. So what does that mean? Well, back in pre-algebra, we learned that if you multiply by 10 or a power of 10, meaning something like 10 to the second power, 10 to the third power, 10 to the fourth power, so on and so forth, you're going to move your decimal point one place to the right for each 0 in that power of 10. So if I have something like 3 times 10, we all know this is 30. But really what I can do is I can start out with 3, put a decimal point at the end, and I can just move it one place to the right because there's 1 0 there. As a more advanced thing, let's say I had 3 times 100,000. So I could start out with a 3, put a visible decimal point, and then I've got 1, 2, 3, 4, 5 zeros. So this would go 5 places to the right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so I would have here 300,000. And a lot of you know that 3 times 100,000 is 300,000. Just another way to kind of think about doing the operation. So when we look at equations with decimals, I just need to look for the largest number of decimal places, and then our power of 10 is going to need that number of zeros. Okay, so it's just that simple. So here's an example. We have negative 1.8x minus 2.06x equals negative 2.9x plus 2.4. So if you want to clear the equation of decimals, and again, this is something that you don't have to do, it's optional, you look for how many decimal places each number is going to have. So this one has 1. This one has 2. This one has 1, and this one has 1. So if I want to clear the decimals from this equation, I've got to focus on clearing with regard to the largest number of decimal places. So that occurs here in this number, right? This negative 2.06. So if I take care of this one, I take care of the rest. So what power of 10 has 2 zeros? Well, that's a 1 followed by 2 zeros, or 100. So if I multiply both sides of the equation by 100, so I'd have 100 times, inside of parentheses, negative 1.8x minus 2.06x. This is equal to, over here, inside of parentheses, negative 2.9x plus 2.4. And again, this is times 100. Let me scroll down a little bit. So I use my distributive property. 100 times negative 1.8x. So let me just write this out. Negative 1.8x. So this is going to move 1, 2 places to the right. So it's going to be negative 180x. Then minus. I'm going to do 100 times this. And again, I'm just moving this 2 places to the right. So this, and then this. So I'd have minus 206x. And this equals 100 times this. So negative 290x. Then plus, again, I have this 100 times this. So 240. Now I've cleared the equation of decimals. So now let me simplify over here. And negative 180x minus 206x is negative 386x. And this equals, over here I have negative 290x plus 240. Now, let me move all the variable terms to one side, all the numbers on the other. So let me add 290x to each side of the equation. So this is going to cancel. I'll scroll down a little bit. And then negative 386x plus 290x is negative 96x. So this is negative 96x is equal to 240. And at this point, we know what to do, right? We have negative 96, that is the coefficient for x. So I divide both sides of the equation by negative 96. And we'll get x is equal to, if you punch that up on a calculator, you get negative 2.5. Now, here's my rule of thumb. If I have an equation that has decimals involved, I use decimals as my answer. If I have an equation with fractions, I use fractions as my answer, unless I get an integer or whole number. In this case, it would not be incorrect to simplify the fraction and end up with negative 5/2. So if I wanted to, I could factor 240 as 3 times 2 times 2 times 2 times 2 times 5. And then I could factor negative 96 as negative 1 times 2 times 2 times 2 times 2 times 2 times 3. So what's going to happen is this will cancel with this. I'll have 4 factors of 2 that are going to cancel. And I'll be left with 5 over negative 1 times 2, or negative 5 halves. So either way you want to report your answer is okay, right? Negative 5 halves or negative 2.5. It's the same value in the end. So my solution set here, I'm going to put negative 2.5 in. And again, right now I'm going to go back and show you that you get the same answer if you work with the decimals and you don't clear it. All right, so remember we have that x is equal to negative 2.5. Or again, it could be negative 5 halves, doesn't matter. So working with the decimals here, if I have negative 1.8x minus 2.06x, you would end up with negative 3.86x. And this equals negative 2.9x plus 2.4. I would add 2.9x to each side of the equation. So that cancels. So over here on the right, I just have 2.4. On the left, I'm going to have negative 0.96x. And then I want x by itself, so I'm just going to divide both sides of the equation by negative 0.96. And what I'm going to get is that x is equal to negative 2.5, just as I saw over here. Now you might say, man, that was really quick. Why would I ever clear an equation of decimals? I would agree with you on that, but I'm teaching it because it does come up in your textbook. You might have to show your work, and you need to fundamentally understand what's going on when you get a section like that in your class. But generally speaking, if you're using a calculator, it is a complete waste of time to clear an equation of decimals. I can't think of any scenario where it's going to benefit. In a lot of cases with fractions, it does make it just easier if you clear the equation of fractions. But with decimals, in most cases, it's not really a productive activity. All right, let's take a look at another example. So I have 1.4y minus 2.359, and this is equal to negative 0.607 minus 0.06y. All right, so I have one decimal place here. I have 1, 2, 3 decimal places here. 1, 2, 3 decimal places here. And I have 2 here. So the highest number of decimal places occurs here and here with 3. So the power of 10 necessary to clear the decimals from this equation would be a 1 followed by 1, 2, 3 zeros, or the number 1,000. So I multiply 1,000 by both sides of the equation. Okay, so I'm going to multiply 1,000 times 1.4. And again, the decimal point is going to move 3 places to the right. So that'd be a 1, a 4, and I would have 2 zeros behind the 4. So that'd be 1,400, and then y. Then minus, if I do 1,000 times 2.359, this is going to move 3 places to the right, and I'll have 2,359. And this equals, if I do 1,000 times this negative 0.607, this is going to move 1, 2, 3 places to the right, and I'll have negative 607. And then minus, if I do 1,000 times 0.06y, I would have 1, 2, and then a third time after that. So basically, let me write this out because it's a little confusing. So 0.06, this would go 1, 2, put a 0 at the end, 3 times. You'd end up with the number 60. So minus 60 and then times y. Okay, so now that we have that, nothing I can do to simplify on each side. I want to move all the variable terms to one side, all the numbers to the other. So let's add 60y to each side of the equation. That's going to cancel. And let's add 2,359 to each side of the equation. That's going to cancel. So what I'm going to have on the left side is 1,460y. And this is equal to negative 607 plus 2,359 is 1,752. So the last thing to do here is to divide both sides of the equation by 1,460. And this will cancel with this. On the left, I just have y, and this equals. If you punch up 1,752 divided by 1,460 on a calculator, you'll get 1.2. So y here equals 1.2. Again, in solution set notation, inside my set braces, I just list one element, which is 1.2. All right, so the last thing I want to talk about today, when you're working with a linear equation in one variable, you have three different types of equations that you're going to encounter. Now, most of the time, you're going to work with something known as a conditional equation. This is an equation that has exactly one solution. So let me just write this down, conditional. And this has exactly one solution. So everything we've seen up to this point has been a conditional equation. As an example, let's say we looked at 5x plus 1 equals 31. This has a solution of x equals 6. Because if I plug a 6 in for x, I would get 5 times 6 plus 1 equals 31. 5 times 6 is 30, so you get 30 plus 1 equals 31. And then 31 equals 31. Same value on the left as on the right. If I plug anything other than 6 in for x, you're not going to get a true statement at the end. You'll have some number equals some other number, and that would be false. So conditional equations have exactly one solution. All right, so the next situation we want to talk about is when we have an equation with no solution. So we have here that an equation with no solution is referred to as a contradiction. So I have an example of one of these, and they're very easy to spot. So if you look at this guy over here, if we go to this equation, we have negative 5 times the quantity, negative 3 minus 5z, then minus 4. Now this is equal to 5 times the quantity, 5z, minus 8, then minus 10. So we'll see what's going to happen here is we're going to end up with some nonsense. You'll see what I mean by that. So if I use my distributive property to start, over here, negative 5 times negative 3 is positive 15. Then negative 5 multiplied by negative 5z would be positive 25z. Now we're done with that. We just have this minus 4 here. So minus 4. And then this equals, on the right side, I'm going to use my distributive property. So 5 times 5z is 25z. Then we have 5 times negative 8. That's minus 40. Then we have minus 10. So let's continue to simplify on each side. So 15 minus 4 is 11. So this side is basically 25z plus 11. Then this equals, on this side we have 25z. Then we have negative 40 minus 10, that's negative 50. Now, what do you see here? If you were to pause the video and really think about why you don't have a solution, what do you see? Well, what you would see if you really thought about it is the fact that you have 25z here and 25z here. If I've got the same thing on both sides of the equation, I can just get rid of it. Because I can always go through and say, okay, minus 25z, minus 25z, subtracting the same thing from both sides of an equation. This cancels, and so does this. But where does that leave us? It leaves us with this nonsense, 11 is equal to negative 50. Okay, let me write here, this is nonsense. Okay, this is a false statement. So your variable drops out. You're left with nonsense or a false statement, however you want to think about that. You know that you have something known as a contradiction. So if you get one of these, the way you write your answer, you can either put no solution, or if your teacher is adamant about you using solution set notation, well then you'd say that your solution set is empty, right? It contains no elements. So you use the symbol for the null or empty set, right? It looks like that. Or again, you can use empty set braces. Any of these would be acceptable if you wanted to display your solution here. All right, so the other type of equation, the last thing we would deal with, is called an identity. So an equation with an unlimited, or you could say an infinite number of solutions is called an identity. Okay, so infinitely many solutions. So here's an example of that. So let's say we're looking at 6 minus 8x. So 6 minus 8x is equal to 3 times 2 is 6. 3 times negative x is negative 3x. and then you have minus 5x. So negative 3x minus 5x is negative 8x. And what you basically have here is the same thing on each side of the equation. So no matter what value I choose for x, doesn't matter what it is, if I plug it in for x, I'd end up with the same amount, right? Because I'd have 6 minus that same amount no matter what I choose. So in this particular case, if you don't catch it right away, essentially when you go to simplify, let's say I subtract 6 away from each side of the equation, that's gone and that's gone. And then let's say I add 8x to each side of the equation, that's gone and that's gone. So you end up with 0 equals 0, which is true. So you end up with a number equal to another number, and the variable just drops out, just gone, okay? So you can just put here that there's an infinite number of solutions. Or in solution set notation, inside of set braces, you can simply write all real numbers. And there's more ways to kind of notate this, but this would be the two easiest ways to write that answer on your test.